Good evening, everyone. So, Johnny, let's start off. This was the last thing that we did. The results have come out now. We have one student who got 100 out of 100 in physics. I think there are three people who got around 95, 90 scores. Yeah, overall people did fine, but this time overall cutoffs went, pretty weird actually. It's like, let me show you something.
So in one paper, 240 was 99 percentile, and then 140 was
If you
99
see na 99 percentile, 27th ka first slot is 236. 27th ka second slot is 211. 29th is two slots, 203, 212. 30th ka 193, 191. 31st ka 170, 151. And 1st February is 161, 172. Meaning the scores went from 151 to 236 ka beech mein. Depending on which paper you are writing, 99 percentile is that. If you look at only physics, 99 percentile. I'll post this in the group also later on. For physics 99 percentile, there are 10 slots, right? 27, 29, 30, 31, 1. So morning, evening. So 99 percentile is like first slot is 87, second shift is 82, third is 81, then 91, then 77, 81, 84, 77, 71, 76. Physics ka percentile went from like 87 to 91 to 91 is 99 percentile to 77. मैथ्स का देखते हैं मैथ्स के लिए 99 परसेंटाइल फर्स्ट शिफ्ट इज 77 सेकंड शिफ्ट इज 61 थर्ड शिफ्ट इज 52 फोर्थ इज 55 फिफ्थ इज 59 52 41 35 36 50 मतलब there is a नहीं this year it is papers which were a little easy people scored like anything people became tough so messed up people are crying that only like it's unfair वो ये अभी कुछ नहीं कर सकते welcome to life. Anyways, that is a scene there. I'll post this in the group later. You can check. That's what I keep telling you. When people say, "Sir, I got 170, फिर भी मेरा percentile कम आया," score 200. Na, there's no point in complaining. What else can we do? It is unfair. If the paper was easy, it actually happened in some cases, right? The physics paper was so easy. You are supposed to score at least 80, 85. You messed up the physics paper. Max paper also is tough. You messed up that also. So what is the point? Anyways, let's see. Yeah, from 2 days, why chal raha hai? People are calling on phones. People who got marks, sir, what to do? People who didn't get marks, sir, what to do? People are crying. So let's see. Yesterday, I was on phone calls for almost 5.5 hours. One after another, one after another, one after another. There is this one person who want to jump out of a window. And don't worry, he's in the first floor only. He's joking, but first I got initially scared. And then his mom said, कुछ नहीं करेंगे sir. First floor, maybe stay in first floor. I was like, that guy was laughing. Nah, sir, I was just joking. Said, yeah, idiot, don't joke at this point of time. I got scared. So, yeah, Mumbai people don't do such things. If they get at all frustrated, so they will take someone and throw them out of the floor, but they don't jump. Let's. The news में ऐसा आएगा. Student scored bad, throw the parents out of the window.
तो
ना
265 वाले को क्या परसेंटाइल आया?
61 को depends on the slot रे. मैं भेजता हूँ वो देख लो. मतलब you're asking your senior with me.
सर आपने बोला था ना आपके बैच से
उसको 99.91 I guess. नहीं इस बार I have around 99 percentile के ऊपर तो around 9 students are there. आ रहे marks आ रहे, we are slowly compiling that. 99.90. उसका physics 99.73. ठीक किया था वो. Chemistry थोड़ा goof up किया 98.8, but ठीक है. But physics में ही scored 95 रहे. इसका score physics का 95, math का 95, chemistry 75. और ठीक है ना. 90 ऐसी when you say 99 percentile, your rank is 12,000 ना. अच्छा लगता है 99 percentile. It means nothing. Rank is 12,000 gods. 12 lakh people wrote the exam. Every 1% is 12,000 students, na? So if you scored 99.9 percentile, then it is 1200. That 99 looks great, but people don't realize it is 12,000 rank. Kidding it. So normally that's what I tell the students. See, at least you should be about 98 percentile. Na? That's a 20,000 ka aspas hoga rank. Then we can switch off to advanced ka preparation ke liye, there is some chance. And 99 percentile to you will get into NIT. NIT Nagpur to seat mil jayega. Maybe not computer science, but electrical or mechanical mil jayega. No. So in thermodynamics, right? When you take a gas, a gas can undergo infrared processes. We will be studying 6 special cases. The first one, isochoric. Now tell me one thing, in isochoric, right? What is zero? dV zero, delta V zero. Anyone? What do you think is zero in isochoric process? dV or delta V?
बेसिकली सेम चीज है ना.
नहीं, दोनों same नहीं है. Very different there. If I ask you which is in the isochoric process, what is right? dV zero, delta V zero, which is better?
So dV should be zero, right?
Now see, if you say when dV is zero, if you take a PV graph, when you say dV is zero, meaning the volume is never changing. This is how the graph looks. But when you say delta V zero, if something starts like this, goes like this and comes back here. Here delta V is zero, but dV is not zero. So dV zero implies delta V zero, but delta V zero does not imply dV is zero. Make sense? When you say dV is zero, the volume is never changing. But when you say delta V zero, only initial and final volumes are equal. Clear? It looks simple, but that will be kind of a theoretical question you'll get. So in an isochoric process, dV is zero. Not delta V is obviously zero if dV is zero. So how do you create an isochoric process? Have a container, insulated sealed box here. This is a heater. So let heat Q go from here and let temperature rise by dt. So what you're trying to study, right? dq, du, dw in each process. So first thing, in this process, the work done, integral pdv is zero because there's no change in volume. Second thing, change in internal energy is F by 2 nr dt. That came from kTg. Third, dq is ncv dt. Let me write it as d only. Now, what is the CV here? So CV here is C is for the molar heat capacity. When you put a subscript V, we are telling you this is a special process where it's a molar heat capacity at constant volume. And using thermodynamics first law, dq is equal to du plus dw. So this guy would be ncv dt. Du will be f by 2 nr dt, and that's 0 there. So we get cv is equal to fr by 2. There, this is important. Where f is the degrees of freedom. Have a look at this. Clear? So we proved here cv is fr by 2. Next thing. We'll make a table in the end, don't worry. Next thing, isobaric process. Again, what is 0? dp 0, delta p 0.
DP.
PP.
So isobaric process. Yep. So dp is 0. So how do we create this process? We have a insulated vessel, and let's take a massless movable piston. And you have a heater here. Now, what happens with this piston here? Let the heater give heat Q and let temperature rise by dt. Now, every time the temperature tries to increase, the pressure also will increase. When the pressure increases, this is what happens. This is P2 into area. This is P1 into area. If you take this as acceleration, we get P1 area minus P2 into area is equal to mass of the piston into acceleration of the piston. But mass of the piston is 0. Therefore, we get P1 is equal to P2. So the pressure will be always balanced inside and outside because of the because it's a massless piston. Now, again, three things we are trying to calculate: work done. So work done dW, PdV. So work done will be integral. Here P is constant. So this will be P into dV, which is V initial to V final. This will be P delta V. We also know PV is equal to nRT differentiate on both sides. This will be PdV plus VdP is nRdt. This term is 0 because pressure is constant. So you can write work done as either pressure into delta V or work done as nR delta T. Both work. So in an isobaric process, the work done is either given by nR delta T or P delta V. Second, du is given by f by 2 nR dt. This comes from kTg. But we proved here just now in the previous case that fr by 2 is nothing but cv. So this is ncv dt. Now again, don't get confused, sir. How can you use cv in a isobaric process? Did I use dq as ncv dt? I didn't use dq as ncv dt. I'm saying du is ncv dt. And the another reason is, as long as the change in temperature is same, the change in internal energy is same. It is independent of the process. Getting it? So Again, I'm telling you, du is still f by 2 nr dt. I proved fr by 2 is cv. I'm just substituting that. cv has nothing to do with the process. Getting it? Since u is a state function, getting it? So du will be ncv dt for all processes. Third, dq is ncp dt there. I'm using a different cp here. So what is cp here? Cp is the molar heat capacity at constant pressure. C means molar heat capacity. P indicates you're using, the process is going an isobaric process. Like I said, because it's a special process, we are giving special symbols for them. There, that's your dw, du, and dq. Have a look at this. Clear? Can I done the page? Don't worry too much about it. Let me put a table in the end. Just go through the derivations, and then we will write we will draw a table for everything. I'm just showing you how we got this. So if you try to combine all three, thermodynamics first law, dq is du plus dw. So this guy is ncp dt. This is ncv dt plus work done is nr dt. So we end up with cp is equal to cv plus r. cp minus cv is equal to r. This is called Mayer's relation. Now what this means is, if you take the ratio dq is to du is to w, it will be in the ratio cp is to cv is to r. Example, there's a question like this. 100 joules of heat is supplied to diatomic gas. So find work done. Now from here you can see du is to w. Can you tell me what will be the answer? I'll give you a minute. Try. I'll give you 30 seconds. I gave 100 joules of heat is supposed to diatomic gas in isobaric process. Then in the out of 100, how much is work done and how much is internal energy? Now, if you look at that, du is to dw is in the ratio of cv is to r. What is cv? fr by 2. Therefore, f is to 2. It is diatomic though, 5 is to 2. Therefore, work done will be 2 by 7 of q na total heat. 200 by 7. And whereas du will be 5/7 of the total. Easy? Yeah, ratio will be 5 is to 2 ratio, right? God? It's not monatomic, diatomic है ये. F is 5. Right, Anusha? Got it, na? Understood? Simple example. That's a simple mensural equation. This is one thing they can ask you. So this thing is important, but there's actually a better ratio later on we will see in a polytropic process. Now, in this, there's one more thing they can ask you. If you're measuring Cp and Cv in moles, so Cp minus Cv will be R, which is 8.3 joule per mole Kelvin. This is valid for any gas. Meaning you take oxygen, helium, anything, it doesn't matter. But if you try to measure Cp and Cv, let's say R, you're trying to measure for oxygen, this is what happens. So Cp minus Cv for oxygen, this will be 8.3 joule. 1 mole is how much? 32 grams. So 32 into 10 power minus 3 kg Kelvin. So if you take Cp minus Cv for nitrogen, if you take in terms of kgs, 8.3 joules by 30, 28, 10 power minus 3 kg Kelvin. So if you see now, Cp minus Cv for oxygen is not equal to Cp minus Cv for nitrogen. If you take in terms of kgs. Getting it? So just be careful with that. There was a question like this in JE once. They asked this only. They said Cp minus Cv for oxygen nitrogen, which are the following relation. They forgot to tell that they're measuring in kgs. So people got confused and they said it is equal. They did give marks for both. Getting this? Basically, you're messing up with the Arga value. If you measure in terms of moles, it's both are same, but the moment you try to measure in kgs, that Arga value changes. So Cp minus Cv is not same for different gases if you measure in terms of kgs. That would be a good theoretical question though. Neil, do keep your cam on. Clear? Any doubts on this? Next one. Abhinav, clear so far?
Yes, sir.
Ali, Aryan, Swastika, got this? Maulika? Next one. Isothermal. Please take your academics seriously. I'm telling you, last 6 months, many people have realized what they did and they started taking seriously, but it became very stressful. Can you imagine people wrote 16 minus 4 is 20 and came from the exam? People are literally crying. What? Sir, I did the kind of mistakes even a 8th standard student wouldn't do. This is the statement that I'm hearing on phones. अभी क्या करेंगे? Some guy started with max. He saw one question, he got blanked out. He simply says, "Sir, I don't know what happened." After 1 hour, when I saw, I did only 3 questions. Said, "Sir, I just got blanked out. I don't know what happened." I said, "This is what I trained you for. Speed test me, I made you write 1 hour with 90 questions. I taught you like how to skip the questions." He says, "हाँ sir, I हो गया अभी क्या कर सकते हैं ना ठीक है now we are preparing for boards right now and then we will again start off for JEE preparation." So in isothermal process, dT is 0. That's a constant temperature. So again, how to create an isothermal process? Have a container. This time have a conducting piston. So when you have a conducting piston, temperature inside and outside will always be same. So that way you can always maintain the temperature. So first thing, du is 0 because dt is 0. Work done is integral p dv, but I know p is nRT by v dv. So this thing turns out to be nRT ln v final by v initial. And therefore dq also will be how much then? So dqq will be, that's your work formula. The work done in an isothermal process, nRT, remember this is ln, not log 10, v final by v initial. If you want to write in terms of log, then it will be 2.303 nRT. Then you can write log, that will be base 10, v final by v initial. In physics, it's always ln only. Rarely we use log. We use it once or twice, but most of the times it is ln. T should be in Kelvin, don't forget that. Now here, what about this thing? So in this process, right, dq is equal to dw. And if you talk about molar heat capacity for an isothermal process, it is 1 by n dq by dt. This will be infinity since dt is 0. That's also a good question. What is the molar heat capacity for an isothermal process? Infinity. Meaning, no matter how much heat I give to the system, temperature will never change. Isn't that the definition of molar heat capacity? Higher the molar heat capacity, more difficult to change the temperature. And if you're going to say temperature will never change, that means you need infinite heat. That means indirectly saying, no matter how much you give, I'm not going to change temperature. Check it out. That's about isothermal. This is a bit of a theory. We'll finish off theory and then solve any problems. Basically, for each process, you should know what is dq, what is du, what is dw. Clear? I hope you have done all these things in chemistry, right? So similar stuff. Next one. Adiabatic. This is important. Out of all the processes that we have, adiabatic is the little messed up one. Derivation is also important because you can get different questions, and that is the idea there basically. So what's an adiabatic process? Can I go ahead, Vidyut? Put down that thing in the red box, no? Remaining is fine. Let's not worry about writing the whole thing down. You'll get the PDF. So let's focus on more on solving and understanding. Some of you stopped sending reports. If you're really working on daily basis, sending reports shouldn't be a problem. I'm not replying for a few of you because I got busy with your seniors. But I do keep seeing who is sending. Keep sending. Yeah, I'm telling you again, if you send a report, I don't get a single rupee from that. I wish I could got some money from it, but still. But when you send reports, it is actually a reminder for you. Whenever you're typing there, you'll realize what shit I did today. Getting it? The reason I tell you to send the report, it is for yourself. Do something about it. Make sure to put more time. I hope everyone is studying at least 4 to 5 hours and you're solving at least, 30 to 40 questions. At least 40 questions per day you need to solve of 2 subjects. There is no strategy, big goal. Kuch nahi hai, I'm telling you now. Wake up at the same time every day, eat at the same time every day, study at the same time every day. Try to maintain a schedule. हाँ एक दो दिन इधर उधर classes है, it is fine, but have a weekly schedule fixed. Don't try to do too many things. If you have 5 hours, plan for 4 hours, and 5 hours में होगा वो. It will take time. Continue working. We got an year. You can still make things much better. So dq is 0, meaning heat never enters or leaves the system. So dq is du plus dw. dq is 0. du is ncv dt. dw is pdv. We know pv is equal to nrt. Differentiate on both sides. So take ndt from here. I just replaced ndt here with this. Bring all pdvs to one side. And vdps to one side. cv plus r will become cp. This will cancel. You end up with dp by p is equal to minus cp by cv dv by v. Mayer's relation. So integrate on both sides. Now here what we do, right? This cp by cv, since we are lazy people who will let cp by cv, let gamma is equal to cp by cv. This is called adiabatic constant. So gamma can be written as cp is cv plus r by cv, but cv is fr by 2 plus r by fr by 2. This thing is 1 plus 2 by f. When I say daily report, whatever you do, you have to send. All academic things, huh? आज पानी पूरी खाया वो सब भेजना नहीं है. Whatever you studied, send that. That could be boards, college exam, कुछ भी है. There's one idiot who used to do that also. Today I watched this so and so movie from 8:30 to 9. I said, यार movie क्यों भेज रहे हो? मैं क्या करूँ उसके साथ? I said, sir, you only send a detailed report every day. I said, yeah. So there, gamma is 1 plus 2 by f. Quite a useful thing. That's the thing which you need to remember. Please have a look at this page. We'll talk about that gamma a bit more. Clear? Now, if I integrate this, integral dp by dp, this will become gamma. Integral dv by v. This is ln p minus gamma ln v plus constant. This will become ln pv power gamma is constant. So this gives PV power gamma is constant. If I use PV is equal to nRT and substitute here, we get TV power gamma minus 1 is constant. Or P power 1 minus gamma, T power gamma is constant. So whenever this adiabatic process, this is the relation between P. Cp is not Fr by 2, Cv is Fr by 2. Cp is Cv plus R, right? There, these are the processes. So gamma we got 1 plus 2 by F. So if someone asks you gamma average, suppose sometimes you have mixtures of gases. Gamma average is 1 by 2 plus F average. So F average would be N1, F1 plus N2, F2, so on till Nn, Fn by N1 plus N2 plus so on till Nn. That's how you get the F average. This was a table which I showed in KTG also, if you remember. There, I'll leave it here. These are the for different molecules. And if nothing is mentioned, we always assume non-linear molecule. So monatomic translation is 3, rotation 0, vibration 0. So if you talk about a triatomic with F degrees of vibration mode, so this is the formula there. Be careful here. Each vibration has, each F mode has, vibration mode has 2 degrees of freedom. This was asked in a mains question, not this year. Simple question. They just asked gamma for a triatomic gas, with they said there are 2 vibrational degrees of 2 vibrational modes. So there, these are all the important ones. The same table we also have in KTG.
Vibrational modes are not there for monatomic, right?
Vibration ke liye, there should be 2 things to vibrate, like a spring. One particle will do what?
No, it will still vibrate about its own position, right?
Then that is only translation XYZ.
Oh, right.
That way. Clear with this? Because there's no rotation, Aryan. What is your doubt? This is what happens when you don't read the notes. जाके KTG में एक बार notes refer करो.
फिर क्या पूछा आपने वही नहीं सुना.
Not you. Aryan was asking something.
Oh,
He was asking monatomic का खुद का spin होगा, right? So why are you not taking rotation? Didn't we do that in KTG? Size of the molecule is negligible. Tau phi omega square I is 0. We don't consider that rotation. Clear? It was there. Next thing. What about work done in this process? Now work done in adiabatic process. Integral PdV goes from V1 to V2. Now I know PV power gamma is constant. So P1, V1 power gamma, P2, V2 power gamma is, let's say, some K, which is a constant. So when I integrate this, this will be K dV power V power gamma V1 to V2. This will become K V power minus gamma plus 1 by minus gamma plus 1. Limits will go from V2 to V1. So this can be written as 1 by 1 minus gamma. You can write this as K V power minus gamma into V2 power 1 minus K V1 power minus gamma into V1. So I'm just writing A power M plus N as A power M into A power N. But K into V2 power minus gamma is nothing but P2, V2. KV1 is P1, V1. There, that's your formula for work done. So work done in an adiabatic process is P2, V2 minus P1, V1 by 1 minus gamma. Or you can also write this as NR T2 minus NR T1. We are using PV is equal to NRT, 1 minus gamma, which is NR delta T by 1 minus gamma. This is the work done in an adiabatic process. It's quite an important formula though. Have a look at this. Clear? Any doubts on this page? Next thing. Now, how does an adiabatic graph look like? Problem is, if you look at isobaric and adiabatic, they look kind of similar. So, but there's a
isothermal.
slight iso and adiabatic. Yeah. So PV graph of isothermal and adiabatic. Let's see. So let's say from this point here, because see, both of them, they look like hyperbolas only. So if you take a common point here, P naught, V naught, let's say they're starting from here. For isothermal, we know PV is constant. Differentiate. This will become PdV plus VdP, product rule. So then the slope will be dP by dV is equal to minus P by V. This is your slope of the tangent at any point. Same thing if you do for adiabatic. PV power gamma is constant. If you differentiate this, you end up with dP V power gamma plus P into gamma V power gamma minus 1 dV is 0. So we get dP by dV is minus gamma P by V. Now can you tell me who is more steep? Adiabatic is more steeper. Now, क्या होता है ना, normally I get confused. I don't know what is happening exactly here. So what I do, I generally take numbers. I'll assume this is minus 1. Gamma is always greater than 1, so I'll assume this is minus root 3. So tan theta minus 1 is what? 135 degrees. Tan theta minus root 3, 120. So 120 is closer to 90, right? Means you're more vertical, you're more steep. So that is how you can remember. Getting it? So if you see the adiabatic ka slope of adiabatic is more steeper. Meaning close to vertical. So now here, if you draw a tangent, let's call this thing theta 1. If I draw a tangent, who is more steep here, the red one or the green one? The red one, right? So who is adiabatic, who is isothermal? The green is iso, the red is adiabatic. And the best part, exam they'll ask a question like this. They'll give a graph like this and they'll give you the angles and they'll say find gamma. How will you find gamma here? If you take tan theta 1 by tan theta 2, that would be minus gamma P naught by V naught by minus P naught by V naught. The slope gives you gamma. That itself is a question, isn't it? This slope, if you divide them, gamma will come out. P and V are same for both of them at this point of intersection. So that is a good question again. They'll give you a graph and they'll give you angles like 120 and 150 and they'll ask you find gamma. Suppose instead of this, what if the graph starts from the bottom? Now, who is isothermal and who is adiabatic? Again, if you look at here, this guy is like this. The red is more steep, no? So when you're going from down, the upper is adiabatic. When you're coming down, bottom is adiabatic. So basically, this guy is adiabatic expansion. This is adiabatic compression. Check it out. Quite a useful graph. You get pretty good questions on this. So the ratio of the slopes of adiabatic to iso will give you gamma of the gas. You always have to draw the tangent at the intersection. So that P by V will be same now, or else how will you compare? Do have a look at this. I'm telling you, thermodynamics is primarily you should know the results. You should know the standard, whatever results or formulas are there. Chapter is quite easy after that, as long as you mug it up. Put it up. Let's see one more. Any doubts on this? Clear? Next one, polytropic process. Now, a polytropic process, right, will be in the form of PV power x is constant. Now, remember, every process is not polytropic. Anything in the form of PV power x is polytropic. Here, x is a variable. Now, if you look at the graph here, x is equal to 0 will give you what? X is equal to 0, P is constant, it is isobaric. So by putting different values of x, I get different processes. If I put x is equal to 1, isothermal. If I put x is equal to gamma, adiabatic. You're getting that x ka value could be anything. Whenever that x ka value becomes equal to gamma, it suddenly becomes an adiabatic. Correct? This is x tends to infinity. That becomes isochoric. Now, in this process, du is same thing, ncv dt. Second, what about work done? Just like adiabatic process, if you remember, P2, V2 minus P1, V1. Because see, mathematically, there's no difference between gamma and x. Max doesn't care. 1 minus x or nr delta t 1 minus x. This is for x not equal to 1. If x is equal to 1, it will become isothermal. So formula is different. Work is nr t ln v final by v initial. Now, if I combine these two, we get dq is du plus dw. This is nc dt. This is ncv dt. This is nr dt by 1 minus x. So we get cv is equal to cv by r by 1 minus x. This is a very important formula. Should definitely mug it up. So from this, if you see the ratio dq is to du is to dw, this is even more powerful than the isobaric thing. Is c is to cv is to r by 1 minus x. So basically the cv talks about internal energy and r into 1 minus x talks about the work done. This is a polytropic process for this thing. Let me show you how they'll frame questions on this. Clear? Let's see a question on this. Yeah, everything is polytropic as long as that x is something. So we have a process here. Helium gas undergoes a process where TV cube is equal to constant. Find molar heat capacity. Simple one, get it. So they'll give you some process like this and they'll ask you find C. Any answers? So we have TV cube is constant. T is proportional to 1 by V cube. And we also have PV is equal to nRT. So PV is proportional to T, which is proportional to 1 by V cube. So PV power 4 is constant. It's a polytropic process. Therefore, X is equal to 4. Therefore, C is equal to CV by R by 1 minus X. It's a helium gas, so monatomic CV is 3R by 2. That is R by 1 minus 4. So that's 3R by 2 plus R by 3 minus R by 3. That's 9 minus 2, 7R by 6. Easy? Have a look at this. Let's see one more. Got this, everyone? So you always have to bring it in the form of PV power something and you're done. If you get that form, it's a polytropic process. Rehan, Palak, clear so far? Paulika? Got this? Udayan, Neil? Great.
This
Next
is
one.
negative हो सकता.
Let's see the next question. Then you'll understand. You revealed it.
अच्छा मुझे
No.
कैसे बताओगे आप क्या करोगे?
Now, we have three processes here. PV power 1.01 is constant. Let's say we have PV square is constant. And let's say we have PV power minus 1 by 3 is constant. And let's say we have something like PV power minus 0.1 is constant. So the question is, in which process, when heat is given to the system, temperature decreases? In which process, when heat is given? So generally, if you give heat, temperature rises. Given, the temperature decreases. This is how they'll ask a question. You have to choose an option. Let's get it. Take this as a nitrogen gas. Basically diatomic gas. The answer for that is what it's asked right now. So you need to think, when I give heat, why the hell the temperature is decreasing? So what's changing there? Try. You got a minute. Easy one. This will be a good matrix matching question, actually. They'll give 4 on the left and 4 on the right, and they'll ask you, temperature rises, volume increases, temperature rises, a heat is given, temperature increases, heat is given, temperature decreases. So they can match up 4 things on either side and can ask you as a matrix matching. Here, I gave everything in PV square. I could even make it like TV, PT, and all that stuff. So, Okay, we have 2 answers so far. Arjun says A, Abhinav says C. Anyone else got anything else? We have 2 C's. We have 3 C's. What's the statement there? dq is nc dt. You're saying when heat is given to the system, this is positive And you're saying temperature decreases. This is negative. Therefore, C must be negative. So if a process has a negative molar heat capacity, when you give heat, temperature decreases. Now, for the first guy, if you see X is 1.01, it's a polytropic, all are polytropic processes. So C will be nitrogen gas, so that is 5R by 2 plus R by 1 minus 1.01. That's 2.5 R minus 100 R. Definitely negative. First option is right, but let's check the others also. PV square, that's X is equal to 2. So C will be 5R by 2 by R by 1 minus 2. This is greater than 0. X is minus 1 by 3. This is definitely positive. Doubt ही नहीं है. 5R by 2 by R by 1 minus of minus 1 by 3. D में 5R by 2 plus R by 1 minus 0.1. This is also positive. A is the only answer. Check. The main idea is that whenever you say I'm giving heat but temperature is decreasing, meaning molar heat capacity is negative. Clear? So yes, molar heat capacity can be negative. Do have a look at this. All clear? Next one. Let's see one more. Let's say we have a PV graph and we have a line here. This is a V naught. This is 5 V naught. This is P naught. This is X times P naught. It's a 1 mole of helium gas. Going from A to B. Molar specific heat for this process. Now I don't know which process is this, huh? And it is not passing through origin. Molar heat specific heat of the process AB is 13 R by 6. Find X. This will be a good integer. Wait, let's make this 3P naught. There is no guarantee this is passing through origin. It all depends on X ka value. How will you do this thing? Just to give you a hint, this is not polytropic. Polytropic is what P, V power something is constant. This is looking like Y is equal to mx plus C. Like I said, a gas can go different types of process. In that, polytropic is one special case. Have a look at this. Try. Everyone should give it a try. Any answers? How do we proceed? I'll tell you one thing. See, you always have one thing with you. Delta Q is delta U plus delta W. So can you find work done in this process in terms of X? And can you find delta U of this process in terms of X? And then write that as NC delta T. Generally, one thing I'll tell you, in every process, right, whenever you're calculating, especially in thermodynamics, the most important quantity that you need to figure out or measure always is temperature. Listen to this statement. Reason why. Why temperature is important. If you want to find delta U, what do you want? NCB delta T? You want temperature, isn't it? If you want to find work done, isobaric formula kya tha? NR delta T. If you want work done in adiabatic, what is the formula? NR delta T 1 minus gamma. If you want work done in isothermal, what is the formula? NR T ln V2 by V1. If you observe, T literally comes everywhere. So first find the temperature at A and B in terms of X, then find delta U, then find work done. Try. I'll give you a minute or two. We will wrap up the chapter on Friday.
So after this, what will you start?
Heat transfer है ना God अभी भी radiation conduction नहीं हुआ. After that, what are they teaching right now? Fluid mechanics, SHM.
Yes, sir.
SHM and fluid mechanics.
Which started first, or which is going fast?
SHM.
SHM is going fast.
So, but can you do fluid mechanics?
Why can't they do fluid SHM? You are a racist. You hate oscillations.
Yes, sir.
Oscillations will take revenge on you. चलेगा, we can do fluid mechanics.
Thank you, sir.
It really doesn't matter anyway. पूरा तो physics करना ही है boss. See, the only difference, you know what? One is like, hitting with a stone. One is like hitting with a rod. Whether you hit with the rod first or stone first, it is the same thing, isn't it? Let's see. First thing, let's find the work done. What is work done? Area under the graph. Area under the graph gives you work. What is area? Half opposite sides 3p naught plus xp naught into the base is 4v naught. 2v naught, p naught, 3 plus x. That's your work. Temperature at A, 3p naught, v naught, mole is 1 mole. Temperature at B, 5x p naught, v naught by r. So delta TAB will be P naught V naught by R 5x minus 3. That's your temperature. So delta UAB, it's a helium gas. So NCV delta T, N is 1, CV is 3R by 2, V naught by R, which is 5x minus 3, 3 P naught V naught by 2, 5x minus 3. What is delta Q? Delta Q for any process is NC dt, isn't it? That's from calorimetry. NC delta T. N is 1. C is given 13R/6. And delta T is the same guy. P0 V0 by R into 5x minus 3. 13/6 P0 V0 5x minus 3. Using thermodynamics first law, we know delta Q is delta U plus W. This thing turns out to be 13/6 P0 V0 5x minus 3 is equal to this is 3 P0 V0 by 2 5x minus 3 plus 2 P0 V0 3 plus x. P0 V0 goes off everywhere. Bring it to this side. This guy would be 13/6 minus 3/2. Multiply 3 and 3. 13 minus 9. That is 4/6. So that is 2/3. 5x minus 3. I'm skipping steps, huh? 2 into 3 plus x. Multiply 10x minus 6 is 3 to 6. 3, 18 plus 6x. Hope I didn't goof up anywhere. So this guy is 4x and this guy is 24. X is 6. Perfect. That's your integer. This is not polytropic process. This is not isobaric. This is nothing. This is nothing, of anything that we have studied so far. This is some weird process. So this is what I was saying. Just because, we learned 5 processes, aisa nahi har baar aisa kuch aana chahiye. You can get some random process also. What you need to remember is the basics. PV is nRT is always valid. Delta Q is delta U plus delta W is valid. Do have a look at this. It's a good one.
So polytropic has to always be some
PV
sort
bar
of a
X.
curve, right?
PV bar X. नहीं, कर्व होने का जरूरत नहीं है ना. If you can have a line passing through origin, then P is equal to KV. Then it is PV per minus 1 is constant, no?
Sure.
That is also
Right. Got it.
valid. Problem यहाँ पे क्या हो गया? It is P is equal to KV plus something. You can't do anything about that. Clear with this? Next thing. Can I go ahead? Any doubts on this page? Please ask. Next thing. Let's make a table. Isochoric, we are finding du, the work done, dq, the molar heat capacity, a relation between PVT. So do make a table this thing here. So if you take isochoric, so isochoric, what is du? Work done is 0. Du is ncv dt. dq is also ncv dt. Molar head capacity is cv. The relation between PVT, volume is constant. Basically, dV is 0. So P is proportional to T. So when you plot a graph between P versus T graph, V1, V2, they'll pass through origin and V2 is greater than V1. This much data I want for each one. Now, can you try for isobaric, isothermal, and so on? Isobaric, This will be NCV dt. Work done is nRP delta V or nR delta T, both are same. This is NCP dt and this is CP. Here dP is 0. If you take a VT graph, P1, P2, we have done this in KTG, so I'm not going to prove or anything there. Then we have isothermal. du is 0, work done is nRT ln V2 by V1. This is infinite. This is also same thing. nRT ln V2 by V1. This is infinity. Here dt is 0. We have isotherms like this. T2 and T1. T2 is greater than T1. You can actually make a separate table. You can draw it. Start doing it. Maintain on a separate sheet. It's useful. When you write it down, you'll remember better. Next thing is your adiabatic. dq is 0. du is ncv dt. It doesn't matter for everything. This guy ka formula is nr dt by 1 minus gamma or p2 v2 minus p1 v1 by 1 minus gamma. Same thing, you can also talk about polytropic. This is also ncv dt. This also will be nr dt by 1 minus x. p2 v2 minus p1 v1 by 1 minus x. The dq is nc dt. This guy is 0. C is cv by r by 1 minus x. And if you see the relation here, pv power gamma is constant. tv power gamma minus 1 is constant. p power 1 minus gamma, t power gamma is constant. And you know the graph between adiabatic and that thing. So I will leave it there. And another important thing here is polytropic PV power x is constant. More importantly, du is to dw will be in the ratio of cv is to r by 1 minus x. These are some fine points there. We have done more detailed in each one, but yeah, these are the standard ones you have to remember. Put it up. You can note it down. You can make a table later also, up to you. But do have a table. You know, if you remember, we did table like this for center of mass bhi kiya tha. Moment of inertia ke liye kiya tha. So these are like some tables which you can make and keep them. That will be better. And when you're revising, right, you just need to see for chapters and finish it off. Put it down. Take a break. Come back by 7:10. This is the most evil thing to do. Huh? Give something to write and then give a break. Isn't? My chemistry teacher used to do that. He used to fill up the full board, which takes 15 minutes to write, and then he gives 20 minutes break. ऑनलाइन में इतना चांस नहीं मिलता कभी कभी मुझे, सो बिकॉज आई रेड एवरीथिंग. टेक अ ब्रेक, कम बैक बाय 7:12. देयर, we physics people are innocent. Any doubt so far? Anything not clear, please ask. Come back by 7:12. No doubt so far? ठीक है, I'll be back in 5 minutes. Carry on. Chalo, let's do some questions. Now, there is one more thing called free expansion. So what's free expansion? This is just a process. Out of all, this is the easiest one. So let's say we have an insulated container. And in the middle, we have a thin membrane. One side it is filled with gas and the other side it is vacuum. Let's say this is P naught, V naught, and T naught, and right side is vacuum. Now there are two things you can do. Let's say membrane is suddenly removed. The whole membrane is just removed. Or the membrane is punctured. You made a small hole. Now, when you suddenly remove it, this is what happens. The gas will start moving, and if you observe, since there's a vacuum on the right hand side, there's no resistance. So the gas just moves to the right side without any resistance. So here there is no opposition. Therefore, work done is zero. But the problem here is, during this intermediate stage, pressure and temperature are undefined. You can define them only when everything is uniform. And then finally, you will reach a stage after some time. The molecules will spread out everywhere. Now, if you see delta Q is zero because it's insulated process, work done is zero. Therefore, delta U is zero. So everything is zero in this process. So finally, if the volume is double, let's say pressure becomes P naught by 2, volume becomes double, and temperature remains same. So keep that in mind. In a free expansion, temperature does not change. Now, in the other process, when you make a hole, the gas is leaking out here. Now, what happens, right? When the gas is going from left to right, the gas which already entered the right hand side will oppose the incoming gas. See, when the first molecule goes, there's no problem. But after some time, what happens? This gas which is going out is being opposed by the gas which is present on the right hand side. So these things are opposing. So this gives you a negative work, whereas this gas is doing a positive work. So the work done by the gas is not zero, but total work is zero. So there's a work done by the gas on the left side, there's a work done by the gas on the right side, but the total work done by the entire system is zero. And eventually, you will again reach the same stage. So it doesn't matter. The leaked gas opposes the incoming gas. Have a look at this. This is called free expansion. And in chemistry, you must have learned reversible and irreversible process. So in physics, every process that we do is reversible only. The simple reason, in irreversible process, right, what happens? Pressure and temperature are not defined instantaneously. So if you're writing the equation PV is equal to nRT, you're talking about a reversible process. So in physics, we really don't care whether it is whatever it is. All processes we do are reversible. There, this is your sixth process. First one is isochoric, isobaric, isothermal, adiabatic, free, polytropic, and free expansion. The other six. Clear? Next thing. Efficiency of a cyclic process. So in a cyclic process, the efficiency, this is the symbol for efficiency, is given by total work done in a cyclic process by the heat given to the system. Only the positive heats. We don't consider negative heats because think of like this: when you put coal into a steam engine, it burns, and all that steam and the smoke that escapes, right? That is a negative heat. So you can't recover that. The rejected heats cannot be recovered. So we don't consider that. We're only interested in what did I give you and how much work I got. Whatever you throw out, that's your problem. So in thermodynamics, this is one type of question. They'll ask efficiency of a cycle. Let's see a few models on that. Clear? Let's start with an easy one. We have a PV graph. V naught, 2V naught. We have drawn the graph for this in KTG. 2P naught. This is A, B, C, and D. It's going this way. N is equal to 1 mole. It's a helium gas. So when you do this question, first find temperature at A, temperature at B, temperature at C, temperature at D. This is the first step for finding efficiency. Second, for the process AB, BC, CD, DA, delta U, work done, delta Q. Fill up this table. If they ask you to find the efficiency, generally you have to fill up this table. Reason, how do you know which one is positive heat, which one is negative heat, right? Third, find efficiency of the cycle. Chal, let's get A and B. If you got A and B, you'll get C automatically. Try, you got 2 minutes. Fill up the table. Find the temperatures and fill up the table. In each process, find delta U, work done, and delta Q. AB and CD are isobaric, BC and AD are isochoric. Let's go. Try 2-3 minutes, then I'll show you. Temperature is easy, PV by NR. Last slide here.
Yes, sir.
I help you with the temperatures. Temperature of A is 2P naught V naught by R. N is 1. This is the same temperature at C. Temperature at B, 4P naught V naught by R. Temperature at D, P naught V naught by R. There, you know the temperatures. Perfect. What is delta U? NCV/dt. What is CV? Helium gas, FR by 2. Fill up this table. You know work done. Add delta U plus W, you'll get delta Q. You'll get everything. Try. I'll give another 2 minutes. Fill up the table. You can just tell me the efficiency ka answer. If you got the efficiency answer, you'll get the table right almost. Put a 5, give it a try. You'll see a few more models on this. One by 6, near. What is delta U for AB? NCV/dt. N is 1, CV is 3R by 2, delta T is TB minus TA, which is 2P naught V naught by R. So this guy is 3P naught V naught. Work done. Isobaric process is NR delta T. N is 1, R, 2P naught V naught. So delta Q is 5P naught V naught. Add them. Delta U plus W. 2 by 5 नहीं याद रहे. Anika, N is equal to 1 का मतलब पता है? 100% efficiency. You have saved humanity from disaster. You will get a Nobel Prize. And make sure to share at least 25% with the teachers for encouraging you to get a Nobel Prize. Next thing, delta U, BC. What is this? N1, 3R by 2. You're talking about TC minus TB. ये minus हो जाएगा. Minus 2P naught V naught by R. So this guy is minus 3P naught V naught. Work done is 0 because isochoric. DA का भी work done 0. This is minus 3P naught V naught. CD ka same thing. D minus DC. This guy will be minus 3P naught V naught by 2. This is plus 3P naught V naught by 2. Now understand, if you add all this thing, delta U net should be always 0. Cyclic process mein delta U net is 0. That is one way to make sure you didn't mess up anything. Because if you start from one point and come back to the same point, delta U should be 0. And here work done would be P naught delta V. So this is P naught V naught minus. So this is 5 by 2 P naught V naught, and this is plus 3 by 2 P naught V naught. Check. You're done. So efficiency will be total work done. Total work done is P naught V naught. You have to take total work, but heats you only take positive heats. That's the reason you need to put a table. How do you know which one is positive and which one is negative? Yasha, you got it. Adrit, Anusha. The total work done is P naught V naught, and positive heats will be only 5 P naught V naught plus 3 by 2 P naught V naught. That turns out to be 2 by 13. Meaning for every 13 joules of heat, only 2 joules is becoming work. You can put into 100, that will give in percentage. Have a look at this. Clear? Let's see one more like this. Any doubts on this? Anything that you didn't clear, goofed up, please ask. This is what I was saying. Whenever I ask you efficiency or anything like work done or anything, remember temperature is the primary thing. 99% of the time, if you start with temperature, you'll get everything. Because you can find works, delta U, everything in terms of temperature. Next one. Let's say this is a VT graph. Every time it won't give you PV graph. That's a line passing through the origin. A, B, and C. T naught, 2T naught, V naught, 2V naught. N is equal to 1 mole and it's a helium gas. Find efficiency of a cycle. There. Now I won't tell temperature and all that. I mean, literally you have to fill the table again. The story is the same. The moment I ask you efficiency, until unless you're sure about positive heats, fill up the table. Get the table for AB, BC, and CA. Delta U, work done, delta Q. Get it? Anyone confused with the previous question or not clear with this, please ask. Don't hesitate. It's a very important model. Get it? Others do keep your cams on. Delta U, work done, delta Q. So A to B is an isobaric process. B to C is isothermal. A to C is isochoric. There, I brought 3 different processes into this. So isothermal delta U is 0. A to B temperature, so I know it's a helium gas. So NCV dt, so 1, 3R by 2 delta T is T naught. This will be automatically minus 3R T naught by 0 because everything should be 0. In isobaric, work done is nr delta T, so 1R, so that will be R T naught, and this guy will be 5R T naught by 2. Isothermal work done is 1 R. Temperature is 2T naught. nRT ln V2 by V1. This is ln V final by this. So this is half. Actually, work done is negative. So this guy is minus 2 RT naught ln 2. Isochoric work done is 0. So this is minus 3 RT naught by 2. So efficiency of the cycle, total work done, RT naught minus 2 RT naught ln 2 by positive heats is only 5 RT naught by 2. So this is 2 by 5, 1 minus 2 ln 2. What did I go for? Please check. Right, Anusha. We got the same. Plus नहीं आएगा God. देखो एक बार. ये minus है ना? This is minus 2 RT naught ln 2. Ln half था वो. Minus आएगा. Check. Easy. This is what I was saying. You fill up the table, finish off. You'll get the efficiency from there. Any doubts on this? Let's see one more like this. This is what I was saying. You should know your formulas for each process. If you know the formulas, it's fine. It'll go off. Next one. Any doubts? Ali, Anika, got this? Arjun, Neil, Maulika, Udian, Rehan, Swastika, clear, na? Palaksh? Perfect. Next one. This is a good one, right? A, B, and C. This is V naught. This is 4 V naught. Gamma is 1.5. Nothing is mentioned about the gas. AB is isobaric. BC is adiabatic. CA is isothermal. Find efficiency of the cycle. C ka volume we don't know. If this was a paragraph question, I would ask you that only. Find VC and find efficiency. If you want to find efficiency, VC to find karna hi padega. Let's get this. Again, I give 3 different processes. Try to fill up the table. Nothing is mentioned. Number of moles is not given. Cancel ho jayega. You take n, cancel ho jayega because efficiency is a ratio. It goes off.
फिर आप पिछले 2 स्लाइड पहले जा सकते हैं
2 slide. Yeah.
नहीं नेक्स्ट स्लाइड
This one. Confused. Which part?
So you were adding U and W to get Q.
हाँ. That is the only way to get it, na? Delta U plus W is Q. Any confusion? क्या कर रहे हो exactly? Use NCP dt क्या? Pressure you don't need, nothing is given at it. कुछ नहीं दिया pressure के बारे में. I'll give you a hint. Like what did I say in the beginning? If you know temperature, you can find everything from there. So start with an assumption. Let the temperature at A be T. Start from there. And let the find the temperature of B and C in terms of T and start solving. Because anyway, it's a ratio will get cancelled. So assume the temperature at A is T and start the problem from there. हाँ उत्साह clear with that? कुछ confusion है? Utsaह, where are you confused?
तो 2 मिनट आई थिंक मैंने कुछ कांड किया.
चलो. Happens. We do all weird things. Still confused? Let me know after that class. Let's start with the temperature at T. A is T. So B का temperature, C का temperature निकालो. Because once you got temperatures, you'll get delta U. So you'll get work done. So you'll get literally everything. You also have to find volume at VC also. Try. I'll give you 2 minutes. Figure it out. This is a good one. I think this was a JE question. I don't remember, but I liked it because there are 3 different processes: isobaric, adiabatic, and isothermal. So let temperature at A be T. So in the process AB, it's an isobaric process. So V is proportional to T. Therefore, TB will be 4T naught. And TC is equal to T only because it's an isothermal process. There, I got the temperatures in terms of T. Matlab, I can find delta U's, na? And in the process B to C, it's adiabatic. TB BB par gamma minus 1 is TC VC. And gamma is 1.5, तो ये आफ हो जाएगा. We get VC 64 V naught. 2 by 7, 1 plus 2 ln 2 by 1 plus ln 2. Wow. That looks weird, Aryan. Let's see. Now let's get the table. AB, BC, C. Delta U, work done, delta Q. A to B, delta U is NCV dt. N you didn't give me, fair enough. CV, let it be CV, delta T is TB minus TA, 3T naught. Work done, NR, delta T, so 3T naught. So this guy would be NCP basically, NCP 3T naught. Same, which is CV plus 3R. Or I can do one thing and write it down for you. B to C adiabatic, so this guy is gone. Work done, this guy would be minus NCV 3T naught. This guy is 0. So work done also will be NCV 3T naught, because delta U is equal to delta W with a minus sign. C2 wave is work done is NR, temperature is T, ln. Now you needed the volume here actually, VA by VC. So that was actually nRT ln 1 by 64. Which is minus 6 nRT ln 2. So heat also will be same, 6 nRT ln 2. So efficiency of the cycle, total work done, 3 nRT naught plus NCV T naught minus 6 nRT naught ln 2 by the positive heats, which is NCV plus 3R 3T naught. T naught goes off. We can calculate from here. Gamma is 1.5, which is 1 plus 2 by F. So F is equal to 4. So CV is FR by 2. So CV is actually 2R. Isn't it? Gamma, so I can find F, and from there I can find CV. N T naught, N T naught, N T naught, N T naught. You're left with 3R plus CV is 6R minus 6R ln 2 by 15R. R also goes off. You end up with 9 minus CV plus CV plus R होगा ना ये. That will be 9R. R also goes off, so 9 minus 6 ln 2 by 9. That's your answer. Right, Yasha? Please check where you goofed up, everyone. Like I said, it is all about filling the table. To fill the table, you need to know the formulas for each process. Please check. Anyone not convinced with any particular step here, not clear, anything, please ask. Utsa, got this thing? Your doubt was cleared? What?
हाँ सर, वो मैंने एक्चुअली डेल्टा यू और डेल्टा क्यू के कॉलम को सर्च कर दिया.
Okay. Anika, clear with this? Aryan, got your mistake? Anusha, Maulika, Lakshika, clear with this? Arjun, Aditya, Abhinav? Any doubts on this? Udayan, Ali? These are some good models on efficiency of a cycle, huh? So I can give any kind of process and I can ask you. Let's see one more like this. Turn in the page. This was a JEE question. Old one, 97. उस time subject था, but let's try. One mole of a diatomic gas, gamma दे दिया. Cyclic process starting from A. Now in this you have to draw the graph. The process AB is adiabatic, BC is isobaric, CD is adiabatic expansion, DA is isochoric. Volumes are given, temperatures are given, temperature of the gas and weight and efficiency of the cycle. So during that time, this was a 10 marks question. So during 2000s and all, the sub paper used to be subjective. Physics 2 hours, maths 2 hours, chemistry 2 hours. So they used to give 2 hours and 6 questions. Each question is 10 marks. So if you can do 3 to 4 questions properly, you'll qualify. This was like a 10 marks question. 97 matlab, I think this is my teacher ka JEE exam. My physics teacher is Alok sir. He's from IIT Delhi. I think he wrote in 97 or he passed out from 97. I don't remember. ये 10 marks नहीं है, 5 marks है ये. Let's get this. First, draw the graph. Put a PV graph for this. That itself is a good one. Put a PV graph for this. And then find the temperatures. Once you find the temperatures, it's done. Meaning you just have to fill up the table and get efficiency. Try. I'll give you 1 minute for the graph. Draw A, B, C, D, PV graph. You got 1 minute for that. Any confusion in the question, please ask. I'll show you the graph. You can verify. Show you. See. First thing, you can't expect an answer directly. We have to do little hidden trials. You are saying AB is an adiabatic compression. Fair enough. So meaning the graph, it's starting from here. It's actually going like this. It's going back. Then you said BC is isobaric expansion. Fair enough. So it looks like this. Then CD is a adiabatic expansion. So again, it looks like this. But then you want DA to be isochoric. Matlab, it should drop down vertically. So D should be somewhere here, A should be somewhere here, and this way should come something like this. There. Approximately, this is how the graph should look. Check it out whether you did this graph right. BC is isobaric, DA is isochoric. And there are two adiabatic processes between them. This is how the graph should look. You got this? Then great. Next thing, find the temperature at B and D. If you draw this graph, you'll get 1 mark. And exam, this is how they'll give you the values, for some weird numbers. So you need not worry about these powers and stuff. Get it, find the temperature of B and I'll give you 2 minutes. Everyone should try. Just give it a try. Let's get some water and come. Oh. Temperature is 909. Yeah, that looks right. TB. Let's see. Now you're going from B to D. Now see, what is the idea here? I know volumes, and you're asking me for temperatures. So when you go from A to B, TA, VA per gamma minus 1 is equal to TB, VB per gamma minus 1. TA to we already know, which is 300. VA by VB ka ratio is given, that will be 16. Gamma minus 1, that is 0.4, will be TB. So yeah, so TB aa jayega 909. Then when you go from B to C, it's isobaric. So here VB by TB is VC by TC. VB by VC by VB is 2 times TB. That will be 18 Kelvin. But TC nahi pucha, D pucha. Fair enough. Then when you go from C to D, again it is adiabatic. So TC VC per gamma minus 1 is TD VD per gamma minus 1. But you need to understand here, VA and VD are equal because it is isochoric. So TC would be 18. VD. So meaning D is same as A. Matlab I know A and C ka ratio. So VA by VB is 16. VC by VB is 2. If I divide them, I'll get VA by VC is 8. Which is actually same as VD by VC because A and C are same. So VC by VD will be 1 by 8 whole power 0.4 is TD. There, he gave the values properly for that. So TD, कितना आ रहा है TD? 18 into 0.435, whatever is that.
791.
791? Okay, 791 it's to check. There, temperatures आ गए सब जगह. Find efficiency of the cycle. Like, now you know temperature at A, B, C, D. Once you know temperatures, you'll be able to solve. Put a table for everything, A, B, C, D. Total work done by total heat. Try. You got a minute for the table. Just write the numbers and leave it. It's okay if you don't simplify. See, 0.13 मुझे actually answer याद नहीं है रे. Now if you try to put a table here, AB, BC, CD, DA, delta U, work done, delta Q. Let's fill up zeros first. AD ka work done is 0. AB का डेल्टा क्यू इज 0, CD का डेल्टा क्यू इज 0. BC will be NCV TC minus TB. This guy is NRT TC minus TB. This guy you can add it up, and diatomic gas. So CV is 5R by 2. So this guy would be, he does NCP actually, it doesn't. There, PC okay. What about AB? AB is adiabatic process. So NCV TB minus TA, NCV TD minus TC, NCV TD minus TC. This guy will be minus NCV TD minus TC, minus NCV TB minus TA. आ गया सब. This is NCV TD minus TC. Put the numbers, calculate positive, negative, जो भी आएगा, efficiency will be total work by only positive heats. This who has the highest temperature? I think something.
In the
We'll have to check it
last
out.
process, yeah,
That is positive, क्या? ये positive है. So there you can put down the works and finish it off. You need to just put numbers there. Clear with the process? There, this is how the last questions on efficiency. Any doubts on this, please ask me. So main thing is getting the temperature. हाँ रे तेरा काम मतलब 2 घंटे मिल रहे हैं ना तुझे. क्या करेगा 2 घंटा? You'll play क्या? लिखना पड़ता है 5 मार्क के लिए. Next one. Last one for the day. Let's do an easy one. In a process, dq is given by du by 2 plus dw by 3. It's a diatomic gas. Find relation between pressure and volume. Now you need to understand one thing. dq is du plus dw is always valid. Other than that, it is also satisfying this condition. It's like PV is equal to nRT, and dq is du plus dw is fundamental for anything. If you give something more, that is additional. Get it? Easy one. It looks weird and dangerous, but it's not actually tough to solve. Try, you got 2 minutes. PV power 5 by 9. Nah, that looks. Answer in terms of P and V. That is a question. What is the question? PV power 5 by 9. I'm not sure. देखना पड़ेगा. Anyone else got PV power 5 by 9? Relation between P and V. मतलब बस वही है. P and V का बीच में कुछ relation. Like minus 2 by 3 PV is equal to 5 by 4 nRT. There you go. Adrit, let's see your answer. It's a pretty interesting answer. You got minus 2 by 3 PV is 5 by 4 nRT. But also know from ideal gas equation, PV is equal to nRT. Therefore, minus 2 by 3 is 5 by 4. Therefore, minus 8 is equal to 15. There, you are a max wizard. See, from first law, you always know dq is du plus dw. So, and you're saying this is also equal to du by 2 plus dw by 3. So what I'll do now, so take dw from here, which is dq minus du, and dump it in the first equation. So we get dq is du by 2 plus dq minus du by 3. Shift it here, 2 dq by 3. This guy is du by 6. So dq is du by 4. I know dq is what? NC dt, calorimetry. What is du? NCV dt. So therefore C is equal to CV by 4. So if C is CV by 4, so maybe I should say something. Assume polytropic process. Generally, when you see the options, you will figure it out. All options will be in terms of P and V power something. So this guy would be CV by R by 1 minus X. Isn't it? So यहाँ से X आ जाएगा directly. And this guy would be minus and minus 3 CV by 4 is R by 1 minus X. And CV will be 5. क्या किया मैंने? 3 CV by 4 था वो. Yeah. Minus 3 CV, this is 5R by 2 is R by 1 minus X. 1 minus X will cancel and minus 8 by 3. So X is equal to 11 by 3. नहीं कुछ तो गड़बड़ किया मैंने. 15 ना वो. 23 by 15. So therefore it is PV power 23 by 15 is constant. Check. So even if they don't mention in terms of polytropic process, right? When you check the options, you will realize it's like PV power 1 by 2, PV power something, PV power something. It's understood as a polytropic. But if you ask me, sir, क्या हर बार polytropic होने का guarantee है? There's no guarantee. Getting it? This was the best example. If you see, na, here I got CV is 13R by 6. This question, if you remember. But this was not a polytropic process, isn't it? This was something else. Be careful. हर बार polytropic होने का जरूरत नहीं है. Put it on. That's the last one for that day. So next class when we catch up, we'll do more problems on this. We will even introduce springs also. We'll have springs and all that nonsense, and it'll be fun. And then we'll do something on heat engines also, which is actually removed from the mains portion, but advanced and bits ka abhi bhi hai. So we will at least finish all the basics and leave it there. And entropy physics mein itna kuch hai hi nahi. Like chemistry mein they have a lot, but physics mein it's just a definition and one basic model. So mostly we will wrap up thermodynamics in the next class. If time permits, we'll start off with heat transfer, conduction, and reduction. Okay, with that, we'll wrap up for that day. The next test rotation is online, so make sure to give it. It is there till Friday night. It's an advanced paper on rotation. So any doubts, anything, please stay back and ask, or else you're free to leave. So take care, stay safe. I'll see you guys on Friday.